Welcome back to HESI Chemistry videos. This is video number 7, and we're going to be talking about electrons. So previously we said that where the electron lives could be called an electron cloud or shells or orbitals. So an orbital is a representation of the probability of an electron being found in a particular spot outside of the nucleus. And the reason that it's the probability of it being found is because the electrons zip around in space so quickly that you can't really pinpoint exactly where they are. So if you've ever seen a big cloud of gnats and there's a bunch of them there, and you can see the cloud, but you wouldn't necessarily be able to pinpoint and follow one particular gnat in that cloud. So think of the electrons as being like that. They are moving around so quickly in space that we don't know exactly where they are at any given time, but we do know in what space they're most likely to be found. So if you are asked about anything with electron orbitals or orbitals in general, just know to associate orbitals with electrons, and it's the probability of being found versus exactly where an electron is found. So atoms and ions are the most stable when their outer shell of electrons is full. And so just think of a shell as a group of orbitals, and different shells around the nucleus can hold different numbers of orbitals and therefore different numbers of electrons. So the first shell, the one that's closest to the nucleus, can hold 2 electrons, and the others can hold 8. And so the goal of the atom or ion is to be as stable as possible, and therefore to have a full outer shell. And there's different ways that it can get there. So either it can be born stable. This is helium. Helium is defined by having 2 protons. Its atomic number is 2. And so when it's neutral, it also has 2 electrons. And since those 2 electrons, the electrons always fill the innermost shell first, so those 2 electrons are in the innermost shell, and that shell is most stable when it has 2 electrons. Helium has no desire to gain or lose electrons, and that's why helium is a very stable gas. Lithium, on the other hand, which is what we used as an example previously when we were talking about how ions form, neutral lithium, because it has 3 protons, to be neutral it also has to have 3 electrons, which it's depicted here. And so the first 2 electrons go into the first shell, and then there's just a single electron out here in the second shell. And ideally it wants a full outer shell. The easiest path for lithium to get there is by losing this outermost electron, because electrons can come and go from an atom or an ion easily, and later we'll talk about why they do that to form compounds. But for now, just think about if this one is out there by itself, the easiest way to get an outer shell of electrons is to get rid of this electron, and then the innermost shell is now also the outer shell. It's the only shell, and now it has 2 electrons in it, and that's why lithium tends to form a positively charged ion, a +1 ion, because that's how it is the most stable. Fluorine, on the other hand, when it's neutral, it has 9 protons. Fluorine always has 9 protons, but when it's neutral, it also has 9 electrons. So the first 2 electrons go in the inner shell, and the remaining 7 go in the second shell. and this one wants to have 8. So for fluorine, if it did what lithium does and loses electrons to become more stable, it'd have to lose 7 electrons. But the quickest path for fluorine to become stable is actually to gain 1 electron. And so right here is the electron that fluorine has gained. And just to review, when it gained that electron, it also got a little bit larger. But now it's also more stable because its outer shell contains the desired 8 electrons. And that 8 electrons is also known as an octet.